So for this example, we have 2 square roots. So what we're going to do is we're going to isolate a square root, square both sides. Sometimes when you have 2 square roots, it may take more time to get rid of them. And we're also going to find out that this example, when we go to verify, actually has an extraneous root. So when you have 2 square roots, you just try to isolate one of them. In fact, in this case, they're both isolated by themselves on either side of the equation. So step 1 in our steps is already done. It's already isolated. So what we're going to do to solve is we're going to square both sides. Now squaring will get rid of our square root sign. So then our equation just becomes 2x minus 5 equals x minus 7. Subtract x on both sides. X minus 5 equals negative 7. Add 5 to both sides. And we get x equals negative 2. Now, when we go to check, because we're told that this is an extraneous root, when we look at our left side and split it up and look at our right side, we go to our original equation. So our original equation was the square root of 2x plus 5. Or is it minus 5? Minus 5. And our right hand of our equation is square root of x, which is negative 2 minus 7. Now when I do 2 times negative 2, I get negative 4 minus 5, I get negative 9, but the square root would still be here, negative 9. And when I do negative 2 minus negative 7, I get square root of negative 9. And you're going to be very tempted to say they're the same. It works. But can't square root a negative. So that means that this answer, put an x through it, write extraneous, because it doesn't work. Because you can't take the square root of a negative. And then there is no answer to this one. It's not a trick question, there's just no answer. Sometimes that happens. You would show this that it's extraneous and say that this one can't be solved. Oh, the question you can do for this one are number 10